Good day, students. Today we are going to look at sequences and series. My name is Olubengalakija. At the end of the lesson, students should be able to state the meaning of sequences and series, define arithmetic and geometric progression, find the end term of an AP and GP, find the sum of an AP and GP, and also find the sum of the first n terms and sum to infinity of a what? Of a GP. Let's go on. A sequence is a set of numbers, and this set of numbers are called terms, and they are arranged in some particular order. For example, T1 means first term, T2 second term, T3 third term. Let's look at this example. If the n term of a sequence is given by this formula, write down the first four terms of the sequence. In this case, what we need to do is to say T1, which is the first term, and that is when n equals to 1. So substitute n equals to 1 where you have n in the formula. And for the first one, you're going to have 3 as T1. When n equals to 2, then you have T2. And when you substitute n equals to 2, your final answer becomes 6. When n equals to 3, which is T3, and you substitute n equals to 3, the final answer becomes 12. When n equals to 4, which is T4, and you substitute n equals to 4, then your final answer is 24. Let's go. Example 2. If Tn equals to this formula, find the sum of the first four terms. So that means we're going to find the first four terms, just like we did in the previous example, and now add them together. So for this formula, n equals to 1, that means T1 is equal to 1 when you substitute the value of n equals to 1. Now when n equals to 2, you have T2, and when you substitute you get 13. When n equals to 3, you have T3, and it gives you 39. When n equals to 4, that is fourth term, which is T4, and your answer is 116. So it is all these numbers or these terms that you are going to add together, and that will give you 473. So the sum of the first four terms is equal to 473. Let's go on. Now, what is an arithmetic sequence? This is a sequence with a constant or common difference between two consecutive terms. Consecutive terms are terms that follow each other, having a common difference. Now, the n term of an AP is given by Tn equals to a plus bracket n minus 1 times d. Or we can change Tn to L when we are given the last term. So it means A is the first term, N is number of terms, D is the common difference, and Tn is what? The n term, where L is what? The last term. Example, the first term of an AP is 9, so that means A equals to 9. The first term of an AP equals to 9, so that means A equals to 9. And the 10th term is 81. 10th term simply means T10. And T10 is equals to 81. So we're going to substitute this formula in the formula for n term of an AP. So we have to find the common difference, 29th term, sum of 13th and 28th terms, then product of 5th and 12th terms. For the first one, n term is equals to a plus n minus 1d, where a is equals to what? A is equals to 9. And when you substitute in the formula, T10 will be 9 plus n is 10. Then we don't know what d is. Then since 10 term equals to 81, then you put it to 81. And at the end of the day, d is going to be 72 over 9, which is what? Which is 8. So the common difference is 8. Then how do we find the 29th term? That means when n is 29, a is still 9. So when you substitute that in the formula, then you get 233 as the 29th term. Question 3. You have to find the 13th term. So do the same thing by substituting n equals to 13 in the formula. And from there you get 105 as the 13th term. And when you do 28th term, it will give you 225. So from the question, you have to add T13 and T28. which is 105 plus 225, which is equal to 330. Hope you understand how to solve this. So let's go. The fourth question says you should find the fifth term and the 12th term and find the product. That means multiply the two. So using n equals to 5, your T5 is equals to 41. And to get T12, that is when n equals to 12, your T12 is 97. And product simply means multiplication. So I'm going to multiply T5 and T12. And that will give me 3,977. Example 2. Find the number of multiples of 9 between 30 and 901. The first multiple of 9 within this range is 36. And the last multiple that can divide 9 is 900. So since 900 is the last number in that range, then 900 becomes the what? The last number, which is L. So I'm going to substitute L to be 900, A to be 36, and dot common difference to be 9. Then when you do that and you collect like terms, then N is going to be 97. It means there are 97 terms between 30 and 900 that are multiples of 9. Let's go on. Example 3. If minus 10, P, Q, and 20 are in AP, we have to find the values of P and Q. Likewise, let's write out the formula for n term of an AP using L equals to A plus n minus 1D. The last term in this sequence is what? Is 20. So L is 20. And the first term is minus 10. And when you count the number of terms here, you have 4. So N is 4. So we need to find the common difference. And when you expand and collect like terms, common difference is going to be equals to what? Equals to 10. Now, for P is what? Is the second term. So I write T2. And when I use the formula for n term of an AP, and I substitute, then I'm going to get T2 to be what? To be 0. So that means my what? My P is equals to what? Equals to 0. Because P is the second term. If I go ahead to find T3, which is what? Which is the third term. Which is the third term. And I substitute in the formula. Then I'm going to have T3 to be what? To be 10. So that means 10 is equals to what? Is equals to Q. Let's go on. We are on sum of an AP now. Find the sum of the first 25 terms of this sequence. So what you need to do is to find this formula for sum of an AP, which is what? Which is n over 2 into bracket 2a plus n minus 1d. And when you substitute n, which is 25 over 2, and a is what? A is 11. N is 25. Now d is what? D is 4 because d, which is the common difference, is equal to what? T2 minus T1. And T2 is 15. So 15 minus 11 is equal to 4. So when you substitute that in the formula, you are going to get sum of an AP to be what? 1,475. 1,475. Let's go on. Geometric sequence now. This is formed by multiplying what? Each term by a constant term. And the constant term is called what? The common ratio. For example, if you have this sequence 3, 6, 12, 24, 48, the first term is 3, that is A is 3. So you can find the common ratio to be what? T2 over T1 or T3 over what? T2. And that is 6 over 3 or 12 over 6, which will give us what? 2. So here we have to find the what? The sixth term. So using the formula for n term of GP, A is 3, R is 2, and N is 6. Then I have 3 times 2 raised to the power 5. 2 raised to the power 5 is 32. So 3 times 32 will give us what? 96. So the system of that sequence is what? 96. Then here I have, if you have 1 over 16, you have x, you have 1 over 4, and you have y, and they are in GP. find the product of what? X and Y. So you need to find the values of X and Y, then multiply. From the formula, T3, which is 1 over 4, is equals to A, which is 1 over 16. R is what we don't know. N is 3. And you equate this to what? 1 over 4, because the third term is 1 over 4. And so you have 1 over 16 times R raised to power 2 equals to 1 over 4. The opposite of multiplication is what? Division. So R raised to power 2 is 1 over 4 divided by 1 over 16. And that will give us 4. So if you find the square root of R raised to power 2 and 4, then you have R equals to 2. If R equals to 2, then X is what? 1 over 16 times 2. 2 here 1, 2 here 8. So X equals to 1 over 8. And how do you get Y? It will be 1 over 4 times 2, which is 2 here 1, 2 here what? 2. So Y equals to 1 over 2. So how do you now find the product? Since X is there, 1 over 8, you multiply by Y, which is what? 1 over 2. And that will give us what? 1 over 16. So the product of X and Y is what? 1 over 16. Sum of a GP. Sum of a GP has two formulas. The first one is when the common ratio is less than 1. And you use the second one when the common ratio is what? Greater than 1. Now for this example, we are to find the sum of the first 5 terms of 4, 8, 16, 32 and so on. So the first term here is 4 and the common ratio is what? 2. And 2 is greater than 1. So we are going to use the second formula. So when you substitute that, you want to find the sum of the first 5 terms, that is S5. So A is 4 into bracket 2 raised to the power 5 minus 1 over R, which is 2 minus 1. So 2 raised to the power 5 is 32. 32 minus 1 is what? 31. 31 times 4, that's 124. So if you add the first 5 numbers of this sequence, we're going to get 124. Let's go at the last slide now. The last slide is on sum to infinity of a GP. And the formula is given by sum to infinity is equal to A over 1 minus R. And from this question, A is equal to 4. And common ratio is what? 2 over 4, which is 1 over 2. And when you substitute in the formula, the sum to infinity will give you what? Will give you 8. And so with this, we come to the end of the class. If there are other questions that you need to ask, you can contact me on my YouTube channel. Thanks so very much, and God bless. Bye-bye.